part 2, we will review synthetic division. Now, we tend to use synthetic division when we're dividing by a binomial, but it has to be a special binomial. It has to be a linear term. Okay, a linear term. And this is considered quicker and easier to do. And most of you guys should remember, we're only in, so if we take a look at this 2x cubed minus 3x squared minus 3x plus 2, we're going to divide it by x plus 1. This is a linear term, because if you think about like y equals x plus 1, that's a line. We sometimes call that a linear factor as well. Now, when we're dividing, as you may recall from Algebra 2, you only are interested in the coefficients. So we're going to write this as 2, negative 3, and 2. Now, I'm not sure how your Algebra 2 teacher taught it to you, but I make a big, gigantic 4, like so. And I always circle this because later on that becomes one of the most important parts for us. That is the remainder. Okay? Now, what we're going to divide by is not by x plus 1. We're going to divide by what we call the 0. In other words, we solve x plus 1 equals 0. So x equals negative 1. And that's what we divide by. So what we're doing is we're going to divide by 0 here. Now, our first rule, you may recall, bring down the 2. And then we're going to multiply. Negative 1 times 2, negative 2. Combine. Negative 3 minus 2, negative 5. Multiply. Negative 1 times negative 5 is positive 5. Combine, we get 2. Multiply negative 1 times 2, that goes up here, we get negative 2. And combine, we get 0. Now, we get a remainder of 0 because it's 0, because the remainder is 0. X plus 1 is a factor. And now, but to get our answer, we look at this part down here. These are the coefficients, our new coefficients. And we start by doing 1 power less. So if I start with x cubed, this becomes x squared. It is called a reduced polynomial. X squared, x, and no x, but I put a plus 2 there anyways. And there's our answer. It's called the reduced polynomial. So let's go and try number 5. I would like to take a few minutes, pause it, and try number 5, and we'll pick up. All right. Now that you've tried it your own, we're going to write down the coefficients: 2, negative 7, negative 8, 16. Draw your big, gigantic 4, and your 0 is x equals 4 this time. Drop the 2. 4 times 2 is 8. This becomes 1. 4 times 1 is 4. We get negative 4. And 4 times negative 4 is negative 16. Whoops, negative 16 here. This right here again is 0. So our remainder is 0. Therefore, it's a factor. We have a factor. That means x plus 4 is a factor of this. It means it will divide into it evenly. So our final answer, write down your new coefficients: 2, 1, negative 4. Look at what the power should be on the variables. We start with x cubed, so we get x squared, x, and no x. But be careful, put a plus there because it's positive. So it's 2x squared plus x minus 4. And there's our answer. Number 6, very similar, the same exact type of problem. What we're going to do, again, divide, because that's what a fraction bar means. So I look at my coefficients. I get 3, negative 1, but notice there's no x term. So just like before, we have to add a 0x. So I'm going to go 0, negative 4. Make sure you put the 0 in the right spot. And I make my big, gigantic number 4. And what am I going to divide by? The 0 is x equals 3. So basically, we're kind of assuming it's going to be a factor by calling it a 0. We get 3. We get, this becomes 9, which becomes 8, 24. 3 times 24, ooh, wow, 72. So we get positive 68. Notice this is my remainder, 68. not 0, therefore not a factor. But what is our answer when we divide? We're going to go 3. This becomes x squared plus 8x plus 24. But notice this time we have a remainder. So what we're going to do is going to go plus 68 over what is it we're dividing by? X minus 3. Always over what you're dividing by. And there's our answer. Number 7, same type of problem, but I know what you're thinking. We're dividing by a fraction. That's cool. Hopefully this will work out nicely. If not, good luck. So we're going to write, so we're still dividing. We get 3, negative 4, 0. Why do we put a 0 there? Very good, very good. There's a 0x right there. And we get a 5 here. Draw your number 4. And we're going to, if we solve this, we get x equals 3 halves. Don't be fancy, it's just 3 halves. Drop it. We get 3. Multiply. All right, this is where we get fun for the fractions. 3 halves times 3 is 9 halves. Basically 4 1/2. If you take negative 4, add 4 1/2, you're going to get 1/2. Multiply. 3 halves times 1/2, 3 fourths. And I'm adding it, so I get 3 fourths. Multiply, I get 9 eighths. 9 eighths. And now I've got to add these. What is 5 plus 9 eighths? Well, that's just 40 over 8. So we get 49 eighths for a remainder. Definitely not a factor this time. So, how do we write our answer? 3, we're starting with x cubed, x squared, plus 1/2 x, plus 3/4, plus, now here's where we have to write this one, 49 over 8 over x minus 3 halves. But we don't like that. So, I'm going to rewrite it, but I have to tilt off to the side here because I ran out of room, as 3x squared plus 1/2 x plus 3/4 plus multiply by the common denominator 8, 49 over 8 times x minus 3 halves. And there's your final answer. That's a hard one. Definitely do number 7 again until you keep getting it right, okay? Because that's as hard as they get, and it's just a fraction work, baby math. All right. Now, let's take a look at something else called the rational root theorem. We've been talking about this idea about when the remainder is 0. Well, just like normal division, the rational root theorem, sometimes called the rational zero theorem, I like rational root theorem better, basically says this: if you're dividing two polynomials, just like in normal division, and the remainder is 0, it means that we have found a factor. And I gave an example here. If we take 12 and divide it by 3, the remainder is 0. 12 divided by 3 equals 4, remainder 0. Therefore, because that remainder is 0, 3 is a factor of 12. And here's what we're being asked to do. Determine which of the following is a factor of our polynomial here. And now they said there could be more than one answer. And it's easy to see because the power is 3, that's our degree. If the degree is 3, that means you can have up to 3 answers. So I gave you 3 choices. So what we're going to do, test it. Now, because these are all linear, we will use synthetic division. So, copy down my coefficients: 2, negative 5, negative 9, 18. And what are we dividing by? The 2. Because this gives me x equals 2. I want to see if this is a factor, so I'm going to divide by it. If the remainder is 0, factor. 2 becomes a 4, negative 1, negative 2. Am I going too fast? You get good at this one. Negative 11, and I get negative 22. My remainder is negative 4, not 0. Therefore, x minus 2, not a factor. Easy breezy. Let's try B. Okay, so same thing. 2, negative 5, negative 9, 18. Make your 4, but this time I'm dividing by x equals 3. 2 becomes 6, becomes 1, becomes 3, negative 6. 3 times negative 6, negative 18. My remainder is 0. So because my remainder is 0, therefore, x minus 3 is a factor. So easy breezy. So x minus 3 is our factor. Now, check C. I want you guys to check C, and we'll go over this in class tomorrow. All right, now, how do we use this? If we're given x plus 2 as a factor, now we're going to take a look at it as an application of the rational root theorem. If I'm given that x equals 2 as a factor, that means that the remainder equals 0. And we want to find the remaining factors in zeros. So I can just divide it because I know the remainder is 0. I'm going to divide it. So I take the 1, 1, negative 8, negative 12, and I divide this by my 0 that I already have, my 1, 0. So I'm going to already write down all my zeros here. I get x equals negative 2. We get 1, multiply, we get negative 2, becomes negative 1, becomes positive 2, which is negative 6, which becomes positive 12, which is 0. So therefore it's a factor. A 0 in other words, and it's a factor. So to get my remaining ones, I look at my reduced polynomial. This becomes x squared minus x minus 6. And I can factor that. So here's all my zeros. I'm going to get 3 of them because of my power here is 3. But over here I'm going to look at my factors. I already have the factor x plus 2. But now I have my reduced polynomial, this x squared minus x minus 6. I can factor that. X minus 3, x plus 2. And if I set them equal to 0, I get x equals negative 2, 3, and again, negative 2. And those are my zeros. All right, so try this one again, and we will talk more about this tomorrow. Bye-bye.